Hi, this is James. I'm going to do a walkthrough of Labs 6, 7, and 8 of Path to Programmable. So we'll start off in Lab 6, and what we did there was we added the BRAM controller from the IP catalog, and we'll get a little bit more to that. So we add that, and we export it over to the SDK, and we run it, and I've actually already got the direct memory access test going. The idea of direct memory access is improving flow between the PS and PL. And what we can see from this diagram here is if you don't have direct memory access with the main switch, full power domain, then from the slave AXI controller it has to go up, it has to go through the CCI, the L2 cache, and then down into the DDR memory. But because this has direct memory access, that we can shortcut that and go straight here into the DDR RAM. And this is illustrated by the test that we do on here. So if I press 1 to move 256 bytes and move it from BRAM to BRAM by hitting 1 again, I actually get almost a 30x improvement. And when it's exaggerated with 2048 bytes, so if I do that, I do BRAM to BRAM again, I get 192, right? BRAM to BRAM, 2048 bytes. And if I do this again from BRAM to DDR4, 198x, and 202. So I'll just watch this number a couple times, and I'll run this a few times around, and it's between 195 and 202x improvement. It's a little bit indeterminate, but it does show that there's quite a bit of difference between how you do that, and what difference it makes if it has to go through the extra steps to get into the BRAM. The next thing was in Lab 7, back over here, we added custom IP, and that was the PWM controller. So we add the custom IP by importing some source code, and we add it to the library. So I'll show you the library here. Okay, so once it's in the library, which is a large part of the lesson was manually adding it, then I can search for it, and I can just grab it from here and drop it in, and it's ready to go. The other things that we added from here were the logic analyzer, which we can see sat right there, and the JTAG to AXI master. So they're all in here in the IP catalog, and the JTAG to AXI controller is listed here. So we add the PWM controller, we export this, and then we come over to SDK and we run it. So I'll go ahead and I'll run that. That shows up as LCD backlight controller, but in my case I don't have that. So I'll go ahead and run this. It'll program the FPGA, and we'll show you that. Okay, that's fine. Okay, so what I've got going on here is I've got the board. I do not have the mezzanine board for this, so I'm just probing it, and I've got my pin on here up on the screen. Okay, so once this is up and running, it should just take another second, then this is going to create a PWM controller, and we can change the brightness from our GKterm console, and we'll show in a minute here how else we're able to control that. Okay, select a brightness between 0 and 9. So if I choose 1, a brightness level of 1, let me just switch that. Okay, so here's the different levels of brightness control. Okay, so 0 is off, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And now if I make an invalid value, let's say I'm here and I push a different letter on my keyboard like the letter G, this creates the exception, value exceeded, brightness reset to 0, and we can see from the screen that went to 0. Okay, so I'll put that back to 1. So that works. It's creating the PWM signal, but there's more. So we've added the logic analyzer. Alright, and so what we can do on here, I had a little visit from my child there. So with the logic analyzer, what we've got connected on here, it can wire in directly behind the scenes to not only the actual output from the PWM controller, but also to the interrupt and the counter and the duty cycle, which are memory locations, and this is an internal interrupt which goes over into here. So the benefit of having the integrated logic analyzer is it can hook in behind the scenes to see what's going on without actually having to surface those outside to physical pins. So we'll launch the hardware manager and we'll see the logic analyzer here. I'll just make that just a little bit larger here, and I'll start with the manual trigger, and we can see on here that we're running right now, and this is what our duty cycle is set to. The interrupt is off and we just have this rolling counter, so I'll just run this a couple of times and we'll see different values come in for that counter. Okay, and so once that's done, we're well into lab 8 now, so this is logic analyzer and the tickle command into the JTAG to AXI controller. Okay, so we can see all of that, and we can see that if I come into here and I change the value manually, like let's say I put it to 9, okay, so we can see that this has updated, and I can manual trigger this as well, and that pulls in the new value right there. The next thing is you can set up triggers. So let me just make this a little bit larger here. I've got a trigger set up in here for the rising edge of this trace, and so if that ever changes, then it'll pick it up. So I'm going to run this to for the trigger, which means that it's locked now just like it would on a regular logic analyzer or oscilloscope. And if I switch back over, I can give other good valid values in here, and as long as that's all fine, even 0 or 9, as long as that's all fine, then we're okay. But as soon as I put an invalid value like the letter G, we see our trace turn off, and in the background you saw this pick up, and we see the transition. So I'll zoom in here. Oops, I click here and I can zoom in. So we can see the transition from low to high of that, and it was able to pick up and trigger on it. Alright, the next thing is, if I pop that back in, our JTAG to AXI, I showed you that block in the block diagram before. So the JTAG to AXI provides sort of a back way in to the bus. So I'm going to start on the tickle console. I'm just going to do a reset. These are the commands that they teach you how to use. I'm going to create a transmission on here with the create command, and this is a write command to this memory address, and this is the data that we're going to use. Okay, so I've created the command, and then I'm going to go send it. Alright, the next thing I have to do is, once that's created, then I'll send it down, and that's with the run command. Okay, so run hardware AXI write transmission. Okay, so as soon as I do that, you can see that this picked it up right away, and it's got a new PWM value. If I manual trigger this, we can see the new value here. We can see the interrupt is low as well because it's valid. The next thing that we'll do is we'll update that command. So it's the same command that we had before, but we're changing the property called data to this value, which that's an invalid value according to the way that the program's written, which means it's going to generate an exception. So I'm going to set my trigger on here. Again, it's triggering on this interrupt. Okay. So I've changed my value, and I'm going to go ahead and write this. And as soon as that happens, we see this goes blank. This triggered right away, and we can see that rising edge, and so now we know what state we're in, and we're able to catch it manually by hooking back into the background of the AXI interconnect bus and pushing over new values manually. So that's what we did in these lessons. Thank you.